question B. Question 1, Kumbe 9, B. Okay. The combustion of a sample aluminium produces 0.25 mole of aluminium oxide and releases 419 kilojoule of heat at standard condition. Okay, so number 1, they want us to calculate standard enthalpy combustion of aluminium. That means we have to have the equation. Okay, so aluminium solid burn in oxygen gas produces aluminium burn in oxygen produces this one aluminium oxide lah, not carbon dioxide, aluminium oxide. Okay, solid. So we are talking about enthalpy of combustion of aluminium. They asked us to calculate standard enthalpy. So we have to balance the equation. Remember that the substance that burn in oxygen has to be in 1 mole. So to balance the equation, that will be half lah, 1/2 here. So then aluminium become 1. So oxygen we have to multiply with berapa nak balance oxygen ni, kalau 3/2, so ini 3/4 lah. Okay, 3/4 nanti dia jadi 3/2. Okay, correct lah. Betul tak equation saya balance ni? Is it correct? Oh, memang diberikan dalam soalan. Okay. Sorry. Memang diberikan dalam soalan. Okay, sorry about that. So it's correct. So we want to find the standard enthalpy of combustion for this one. Information they give is combustion of a sample aluminium produces 0.25 mole of aluminium oxide, releases 49. Okay, so combustion of sample aluminium produces, that means we have to see from the equation, from the balance equation. Kita akan tengok stoichiometry. Kalau anda tengok stoichiometry, half mole aluminium oxide produces 1 mole aluminium, right? Half mole. So from question info dia berikan 0.25 mole aluminium oxide. That means kita akan dapat, kita tengok berapa mole aluminium, okay. 0.25 divided by 0.5, I get 0.5, 0.5 mole aluminium. Okay, so apa yang kita dapat ni adalah, dari segi soalan ni, I think I read it lah, letak turquoise lah. So from this question, ini adalah mole aluminium yang terlibat. Tapi kalau anda tengok, enthalpy of combustion, dia mesti untuk 1 mole aluminium. Okay, so apa yang kita akan buat next statement adalah 0.5 mole aluminium, it releases berapa tadi? 419 kan? Minus 419, correct. Minus 419 kilojoule. So therefore, 1 mole. Why 1 mole? Because we are referring to enthalpy, standard enthalpy of combustion. So, jadi 1 mole sama dengan negative 419 kilojoule divide by 0.5 mole. So, kita tengok berapa dapat. I get minus 838 kilojoule per mole. Dapat ke? The first one.
Dapat, sir.
Dapat, Okay, so saya ulang balik. Untuk equation ini, saya tak perasan tadi dia orang berikan dalam soalan. Saya pergi balance, tapi samalah. Okay, so this equation stands for standard enthalpy of combustion of aluminium. And then kita tahu standard enthalpy of combustion mesti untuk 1 mole aluminium lah. Okay, daripada equation ni, apa yang kita dapati adalah half mole. 1 mole aluminium equivalent to half mole aluminium oxide. Half mole, 1 mole. So kalau kita gunakan 0.25 mol, ini dapat dari persoalan lah. Jadi berapa mol aluminium terlibat? So 0.25 mol release 419 kilojoule. Kita boleh sebut macam itu. Ataupun 0.5 mol aluminium pun release 419. So dia membawa maksud yang sama. Either you say 0.25 mol of aluminium oxide, which is produced by 419 kilojoule of heat, or you say 0.5 mol of aluminium reacts to produce 419 kilojoule of heat. So ini untuk 0.5 mol, tapi bila standard enthalpy of combustion dia mesti untuk 1 mol. Jadi we calculate for 1 mol, we get minus 838 kilojoule per mol. Right? Now B2. Slide 16 B2. Okay, B2, determine the enthalpy of formation of aluminium oxide and write its thermochemical equation. I think I prefer to write the thermochemical equation first, baru kita carilah. So, we are looking for enthalpy of formation, bukan standard, enthalpy of formation. So, we are looking for aluminium oxide, which is a ionic compound solid. So, elemen-elemennya adalah aluminium, solid dan oxygen gas. Okay. So, we try to balance the equation. Remember, definition of enthalpy of formation is heat change when 1 mole of compound form from its element. Okay, so element dia, aluminium, balance 2. Oxygen 3, so 3/2 lah. Okay. So we get this equation. This equation is the thermochemical equation. So satu kita padam lah. Kejap Okay, betul lah. Alright. So aluminium 2, oxygen 3/2 lah. So the equation is balanced. We got enthalpy of formation. This is the thermochemical equation. They asked to find the enthalpy. Okay, from the enthalpy we can see here, from the B1, kita pergi ke B1 sekejap. Okay, if you go to B1, we already have the idea. Kita ada idea ni, saya nak pen hitam lah. 1 mole aluminium, they give 838 kilojoule of heat. So, what we do here, we can make the statement, 1 mole aluminium give out 838 kilojoule of heat. Okay. If 2 mole aluminium, macam mana saya tahu 2 mole aluminium? Because our stoichiometry is 2 mole. So I take 2 mole lah daripada sini 2 mole. So 2 mole aluminium, that means, bukan equal sign, minus 838 times 2, that will be, alamak, mana ni? Times 2, I get minus 1676 kilojoule. Okay? Boleh? So, our conclusion, enthalpy of formation of aluminium oxide is equals to 1676 kilojoule per mole. Because per mole ini merujuk kepada yang ini 1 mole ni. Bukan rujuk kepada yang ini not that one. Dia rujuk kepada aluminium oxide. Perhatikan apa yang saya tulis di sini, aluminium oxide.